In this video, we are looking at the review for Chapter 2, and I'm on page 40 in the textbook, and I'm not going to add any notes. We have already done all the notes that we need to do this review. So let's take a look at pages 40 and 41. I believe that's all, yes, and we will take these a problem at a time. Number 1, the directions are to read each question and select the correct answer. And they give us a model representation where I have a flat and 5 rods minus a flat, 2 rods, and 7 cubes. So the first thing I'm going to do is interpret the model. We know that our flats are worth 100. Each of these is worth 10, so there's 10, 20, 30, 40, 50. So that's 150 minus 100, 10, 20, 7. So the problem is 150 minus 127. And I will work this for you with the algorithm in just a second. But let's use it to do, let's do the problem with the model. I think that's what they're trying to get me to see. So I'm going to actually erase these numbers. And I'm going to start over here with the second one because it has some singles, some cubes. And I'm going to take a look here. This number, again, is 127. And this number is 150. So I cannot take, let me come back to my problem here. I cannot take the 7 from the 0. So I'm going to borrow from this 5, that would leave 4, and I'm going to make this a 10. And so I'm going to do the same thing here. I am going to take this rod out of the picture and turn it into 10 of those single units. So I have renamed the 150 into 100, 40, and then 10. And you can see that that's exactly what's happening right there. I have one flat, 4 rods, and 10 of those singles. And now I am able to subtract because what I'm going to do, or we're going to do, I'm going to use these singles and these singles and find the difference between them. And we do that by canceling out singles. So I take one of these and one of these, 1 and 1, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. So I am left with 3 here, and that corresponds to those 3 right there. So we're left with 3 singles. Now I have 4 rods and 2 rods. So when I do this canceling process, I would take one of these out and one of these, another one here and another one here. So I'm left with 2 of them, and 4 take away 2 is indeed 2. And then when I cancel the flats, I'm left with no flats at all. So my answer comes out to be 2 rods and 3 cubes, or 23 as my answer. And if you understand what I just did there, you get an A+ on this chapter. If you do not completely understand what I did there, it's okay. This is confusing. It's a weird way of looking at things. Don't stress about it too much. If you are able to get this answer, you're in good shape. If you have no idea what I just did there, and you've watched all of the videos. Now, if you've skipped around, you may not understand everything. But if you've watched every video and you have absolutely no idea what I'm doing, it's okay. You need to talk with your instructor, and he or she can help you get this straightened out. All right, number 2. Which correctly shows the break apart strategy to add 68 and 21? So again, I'm going to use a model on this one. I have 6 rods, 1, 2, 3, 4, 5, 6, and 8 ones. Okay, and then on 21, I have 2 rods and 1 single. So that helps me to visualize. Let me separate those so we don't get them confused. That helps a little bit, okay? But they're wanting me to combine this in a different way. They want us to think about this in a different way, which is why I drew the model. So let's take a look right here. How many single units do we have in all? We have 8 above the line and 1 below the line, so that's a total of 9 of them. So we have 9 of those ones. And then how many of these rods do we have in total? We have 6 above the line and 2 below the line, so that is 8 of them. So we have 8 rods, 9 ones, and remember rods are tens, so you have 8 tens and 9 ones. So I like this answer right here. It really, really helps if you understand the rods, the cubes, and the flats. And if you skipped those videos because you thought those were too easy, that may be what's wrong if you're missing this problem. Okay, number 3, it wants me to solve, and I'm going to use the algorithm because it's already lined up in that form. And at this point, if you can do the algorithm, you are fine. You do not get to use a calculator on this question. So 2 ones and 6 ones make 8 ones. 9 rods and 5 rods, that's a total of 14 rods. So I'll put 4 of them down here and 10 of them up here. So 4, 5, 6 on the flats. I'm thinking 648 will be my answer. And that's just using the algorithm. And when I was in school, that's really the only way they taught us. They just taught us how to do the algorithm. They didn't teach us to think about what the algorithm means. Number 4, what is the missing number in the bar model? So we know 148, that is our total. And we know one of the add-ins here, that's 67. And then we are looking for the missing number. So we're going to take the total minus the one we know. So 8 ones minus 7 ones leaves 1. And then 4 minus 6 I can't do, so I will rename this one as 10 rods. And 14 minus 6 is 8. That 0 comes down. So the missing number in this problem is B, 81. But having done a lot of those examples, hopefully that's going to help you set up the problem to know how to solve it. Number 5 is a story problem, so let's work it that way. A parking garage can hold 75 cars. There were 53 cars in the garage, then 12 more cars drove in and parked. How many more cars can park in the garage? So here is the question. We do have a very, very important keyword or key phrase, and that is how many more. And I've told you with these that means subtraction if that phrase is in the question. I'm going to set up a model for this one, and I need a piece of scrap paper. So let me add a blank sheet, and I actually want to copy this problem so I can remember what it says. So let me grab a highlighter, sketch, we'll take a picture of it, and I'll move it on over to let's try that one, see if it works, and it may not. Nope, it didn't. Sorry, I didn't think it would. I need to take a screenshot right here instead of copying. So let me highlight, and I will tell it this time I want to take a picture of it instead of just copying it. And so let's go to this one and paste it, and then we can work the problem. Now I'm not finished figuring out what's going on here because I have some numbers that I need to look at. I know the total that the garage can hold is 75. I know that we have 53 cars. We have 12 more cars, and we want to know the unknown, and that is the number of empty spaces available. So I'm going to set up a model. I'm going to draw myself a bar and follow that process that you've learned. It'll work every time. A total is 75. That's the number of cars that can fit in the garage. And then we have 3 different variables. We have the 53 that were in there. Let me just say cars instead of. And then we know that we had 12 more. That's adding 12. So 12 more cars. And then we are looking for the unknown, the number of empty spaces that can be filled. So these numbers are our greens, and this is the unknown, the thing that we're looking for. So I'm going to say 75 total, subtract the 53 and the 12 combined, and that will leave me with the unknown. And let me highlight that for you. That's the unknown. Here are the green ones, and here are the total cars. So 75 minus, and we need to do this. So I'm going to use some scrap paper right here and add 53 to 12. That's 3 plus 2, and then 5 plus 1. That's 65, and that will equal the rest. Now we can use one of those mental math strategies right here because the ones are going to cancel each other. Let me just do the algorithm rather than, if you can do the mental math, that's fine. If you can't, it's okay. Just come over here to the side and do the subtraction. So 5 take away 5 is 0, 7 take away 6 is 1. So that leaves me with 10 of those empty spaces. So 10 more cars can come into the garage. And that's the answer we want in our question. So I like answer A for this one. 10 more cars can come in. Story problems are always a little bit harder because you have to set up the math, and that's always tricky. All right, number 6. This is another story problem, but it has models already drawn, so I think we can get away with not drawing this one. Sonia earned $45 on Saturday and $54 on Sunday. Which bar model represents how to find how much Sonia earned over the weekend? So we are looking for the total. We want to know how much she earned over the weekend. All right, we know that she did 45 on Saturday and 54 on Sunday. So the unknown is the total, the weekend total. So I am looking for green sections of 45 and 54. Okay, let's take them one at a time. We don't know the total, so it cannot be A. This one, total's missing. That's good. But here we have 45 and 45. We need 45 and 54. Here, 45 is not the total. 45 goes here. So the one we're looking for is going to be this last one, where we don't know the total, but we know 45 and 54. This would be Saturday, and this would be Sunday, and this would be the weekend total. So the answer you want here is D, as in dog. Number 7, I'm going to use the algorithm because it's already set up that way. 324 minus 183, and that's going to be 4 take away 3. Can't take 8 from 2, so let's borrow to get a 2 and a 12. 12 minus 8 is going to be 4, and then 2 minus 1 is 1. So for this one, I like answer A, 141. Number 8 is a story problem. Winnie has 47 minutes until her doctor's appointment. She spends 14 minutes at a coffee shop and then drives 12 minutes toward her doctor's office. How much more time does Winnie have to get to her appointment on time? So here's the question. How much more time does Winnie have to get to her appointment on time? The key phrase is how much more. If you're seeing that in a question, you're going to need to subtract somewhere. So let's look at what we know. We know 47 minutes. Oops, wrong color. That's the total. That's all the time she has to work with. 14 minutes was at a coffee shop, and then drives 12 minutes. Now here's a key word that I want to point out to you. The word and, that means to add. So when we go to solve this problem, you'll see where that comes in. So I'm going to highlight this one and take a picture. And I am going to go over to my scrap paper for this one, because I need to draw a bar model or some kind of model. So you know how this works. Draw your bar, that's your total. And we do know the total. We know that she has 47 minutes before she has to be to her appointment. So I'm going to put that up here. And so then I'm going to put all the other minutes that I know in the bar. Whatever this total unit is, has to be the unit for the bars. You could not put hours in here or days. You have to put minutes. So we know that she spent 14 minutes at the coffee shop. And we know that she drove for 12 minutes. And that is the green information. And so the pink information, the thing that we don't know, is how much more time she has. How many more minutes does she have to work with? So to set this type of problem up, you're going to take your total minus those two green pieces, and here's where that addition comes in. That word and is that plus sign right there. The word and is that plus sign. And whatever that answer is, that will be the number of minutes she has left. So if you want to see it in color, this is the unknown, this is the total, and these are the pieces we know. So we're going to start right there. I need to know what 14 plus 12 is going to be. That's 6 and 2, so that becomes 26. And then you bring down your total, and that will give us the time left right here. So I'm going to say the total is this one. Over here, I'm going to say 47, take away 26. That would be 1 and 2. So she has 21 minutes left over. That is the unknown piece, and that's the answer we want to choose. So going back to my problem, right here, the answer is B as in boy. 21 minutes to get to the doctor's appointment on time. All right, number 9 is an algorithm problem where we have 44, 13, 21. On these types of problems, you want to make sure that you line up carefully, that everything is lined up in a straight column. So here I have 4 plus 3, that's 7, plus 1 more is 8. Here I have 4 plus 1 is 5, plus 2 more is 7. So I like answer C, as in Charlie, on this one. All right, let's look at page 41. Which correctly shows the break-apart strategy to add 326 and 501. So I'm going to come up here and I'm going to use a model. You don't have to, but this is a good one for me to show you the model. So 326, that's 3 flats, 2 rods, and 6 cubes. And then 501 is going to be 5 flats, no rods, and 1 on the cubes. So let's take a look at our finished product. I have 7 of those cubes. So I'm going to just mark it right up here. Right here. We're going to call this 7 cubes. Then we have 2 rods. And then we have 5, 6, 7, 8 total flats. And so this is going to help me tremendously because I have 8 flats, that's 800. Let me do it here. 2 rods, that's 20. And 7 cubes. So I am looking for this answer, and we've got it right here. 800 plus 20 plus 7, or 827. Number 11, this is a story problem. Johanna has $935. She pays $479 for rent. How much money does Johanna have now? So the unknown is how much money she has now. We know that she had a total of $935, and we know that she paid her rent. So if you want to draw a model of this one, you can. You don't have to if you don't need it. But the total Sorry. Total is $935. We know that she paid rent. That was $479. And we want to know how much she has left. When you know the yellow number, the total, you're going to subtract to solve because you're looking for one of these smaller pieces. So this one is 935 minus 479. And I'm going to do that right over here. 935, 479. Have to borrow. Make that 15. 15 take away 9 is 6. Have to borrow again to make a 12, and that would be 5 and 4. So the missing amount of money is $456. And here are those pieces laid out for you in color. So the answer we want is B as in boy, $456 left in her account. Number 12. Brian made 12 deliveries on Friday and 19 deliveries on Saturday. Michael made 22 deliveries on Saturday. Which set of equations will help find how many more deliveries Brian made than Michael? Okay, this is a tricky one. So I'm going to bring this over. I want us to think about it first, and then we will, I'm not sure that's going to work. Yes, it is. Okay. So why is it not doing that every time? All right, anyway, here comes the problem that we need to solve. So let's do a markup so we know what we're looking for. The question is how many more deliveries Brian made than Michael? So there are some key phrases here. There's that one. There's also this word than. And both of those mean subtraction. So I know at some point I'm going to have to subtract. So let's look back at our choices. I'm not sure this will work. Okay, it doesn't want to let me go backwards. All right, so here are my choices. It will work. I can eliminate A because there's no subtraction. And we know that we have to subtract. So take that one out. Let me do it with ink so it doesn't look like I'm choosing that one. The others have subtraction, so those could be possibilities. But A, I can eliminate because there's no subtraction. All right, let's go back to our problem and continue working on it. So we have Brian. And this time I'm going to do something a little bit different. I'm going to change colors so that you know I'm doing something different. I'm going to use blue and orange on this one. So we know that Brian made 12 deliveries on Friday and 19 deliveries on Saturday. So I'm going to come down here and I'm going to make a bar for Brian. So this is the Brian bar. And we know that Brian did 12 deliveries on Friday and 19 deliveries on Saturday. So this time I'm looking for Brian's total, which means I need to add those numbers together. So 12 plus 19 is going to be 31 total deliveries for Brian. Okay, and that is just Brian that we're looking at here. So I'm going to go back to my choices and see if we find something similar to that. So coming back over here, okay, I don't like answer B because it has no addition. And we know that we had to add. So this one is not the choice because there's no addition. So here we have 12 plus 19 and we have 12 plus 19. Look at this. Both of those have the 12 plus 19, but you have to look at the answers. 12 plus 19 is 27. No. 12 plus 19 is 31. So at this point, I know the answer is D, but I am going to go ahead and finish the problem so you can see why it's D. We know it's D. It has to be because 12 plus 19 is 31. But let's finish our problem. All right, I'm going to make a bar model for Michael because we want to look at Michael's information as well. And I still have not subtracted, and that's important. I have to subtract because of those keywords. So let's draw another bar. We're going to call this one Michael. And I'm going to go ahead and color that so we know Michael. We do not know Michael's total, but we do know that Michael made 22 deliveries on Saturday. We do not know this answer. We can assume that maybe Michael didn't make any deliveries on Friday. I guess that's what they want us to assume, that he did not drive on Friday. So there were no deliveries for Friday. So now we want to know how many more Brian did than Michael. And that's where this pink section comes into play. And to find how many more, I would need to take 31 minus 22. And let's go ahead and finish it. 11 minus 2 is 9. And then that would be 0. So Brian did 9 more than Michael. But we don't have to say the 9. We just have to tell which equations we would use. And that's going to be answer D. That's the one that fits what we did. That's a tricky one. I don't think we've seen one like that. Or maybe we did and I don't remember it. But all right, number 13. I can already tell I'm going to need to take a picture of this one. So let me do that. And then let's go back to scrap paper. Gonna put this one down and let's read it. Ricardo answered the phone 16 times on Tuesday, 23 times on Wednesday, 37 times on Thursday, and 19 times on Friday. How many phone calls did Ricardo answer this week? So I'm going to draw my bar. And I have Tuesday, Wednesday, Thursday, Friday. So I'm going to section off those sections. There's Tuesday, Wednesday, Thursday, and Friday. Doesn't have to be perfect. 16 on Tuesday. And let's go back and get our numbers here. We have 16 on Tuesday, 23 on Wednesday, 37 on Thursday, and 19 on Friday. And then let's bring those numbers into our model. 23 on Wednesday, 37 on Thursday, and 19 on Friday. I also want you to notice this word right here. And. That's your total word. That's the one that says you need to add. So we are looking for the total. We want to know all that week, how many calls did he get? So this is the total, and total means to add. So I'm very carefully going to line up my numbers. Don't let that column lean or you might get tripped up. All right, let me show you how I look at this one. I see right here that I have a 10, 7 and 3. So there's 10 plus 9, that's 19, plus 6 more, so 19, 20, 21, 22, 23, 24, 25. So put down a 5 and carry 2 rods. And then I'm going to come down this column right here and add those together. So I have 2, 3, 4, 5, 6, 7, 8, 9. So the total number of calls was 95. And let's pick an answer for this one. And there it is. The answer is C, as in Charlie, 95 calls. What is the missing number in the bar model? Well, it's the total. It's the yellow number. So we need to add to get that number. And I'm going to use an algorithm right here of 423 plus 398, 8, 9, 10, 11. 9 and 1 is 10, plus 2 is 12, 4, 5, 6, 7, 8. So the total is 821. We want to know the total for this one. We're looking for that top number. All right. Which equation shows the final row of the problem? Okay, I know this looks funny, so let's take it slowly. This one is going to be 5 flats, or 500, 4 rods, or 40, and 8 cubes. Then I have 200, 3 rods, that's 30, and 5 ones. 8 plus 5 is 13. 40 plus 30 is 70. And 5 plus 2 is 700. Ooh, I would not have left it right here. I would have gone ahead and renamed that, but they didn't. So the only answer we can do is this one. Answer D matches that last row. And that would be the answer we want to choose. Number 16. Cal opens a bag of potatoes containing 61 potatoes. He peels 12 potatoes. How many potatoes are in the bag now? So the question, how many potatoes are in the bag now? We know that there were a total of 61. We know that he peeled 12 of them. So it's going to be, if you want to do a bar, you can, where you have 2 variables. You have the ones that he peeled, which were 12. And you have the ones that are in the bag now. That's the unknown. And you have the total of 61. So the bar model will absolutely work here if you want to take the time to draw it. If you know that you need to subtract, that's fine. You don't have to draw the model. But if you're not sure what to do, sketch the model and it will help you to know. So we're going to say, can't take 2 from 1, so let's borrow and make an 11. and that would leave with 9 and 4. So there are 49 potatoes still in the bag. That's a lot of taters. That was a big bag of potatoes. Number 17 is already in algorithm form, so I'm going to follow that. And we have to borrow, so we will make this a 7 and this a 14. 14 take away 6 is 8. Have to borrow to make 17. That's another 8, and then that 1 comes down. So the answer here is 188. I don't know the story about that problem. It's just a group of numbers that I need to subtract. This one, I love these when I don't have to draw them. So they have already given us the model drawn out, and we are adding on here. So we have 2 flats, that's 200. We have 2 rods, that's 20. And then we have 5 cubes, so that would be 225. Then we have, let me change colors. It's a little easier to follow. I have 1 flat, 4 rods, and 6 of those, so that's 146. And we're combining those. So before I do the algorithm, let's do it the way I'm supposed to. So I'm going to add up my flats. There are 3 of them. So that's going to give me 300. Don't know what that is. 300s. Then I'm going to add up the rods. I have 2 and 4. That's a total of 6, or 60. And then I have 5 and 6. That makes 11 ones. So I'm going to take this rod, the 10, and I'm going to move it over here. So I'm going to move 1 rod over. That would be 10. So it's gone from here. So I'm left with 371, or 371. And if you do the math here, you're going to get 11, carry 1, 4, 5, 6, 7, and 3. So either way you do it, you will get D as your final answer, 371. We will do the review in the workbook as well. So if you want more practice, that will give you more practice. But if you are able to handle these 2 pages, 40 and 41, you're in really good shape. And if you did well on this lesson, we're ready to move on to chapter 3. I believe it's going to be multiply and divide, but let me see. We've covered a lot of ground, and I'm still looking. Yes, we will start with multiplication and division in the next one. Also, don't forget about your notes. You need to review these often. We added quite a few notes in this chapter. So if you look at this, if you look at the notes we've added since we started, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, looks like 10, 11 pages of notes just in those first 2 chapters. So review those notes often. We will add some more notes in the next chapter. So I'll see you soon. Bye-bye.